Okay, this is video for the project assembly. So before we start, um, we didn't in didn't introduce the lab 6 in the past, I think. Anyway, so the basic concept of assembly and drafting is in lab 5. I think it's called lab 5 on web course. Um, you can take a look. Okay, we have a very detailed video on YouTube somewhere. Um, anyway, so you need to understand and know the names of these constraints, the assembly constraints, and let's see. Yeah, so those constraints, and you also need to generate a draft for one of the parts. So that'll be detailed in the guideline for the project. So everything's here. And after you read this and try some out, you should be able to assemble this part. But here I'm gonna show you what I did in my assembly anyway. Okay, so just need to show thing here. Okay, so that's the assembly. Okay, you don't have to have the same angle as mine. All right, let's turn this off. Before you start, you want to make sure you have one folder with all the parts in the same folder, because by default NX will look for the parts within the same folder as the assembly part. So that's the catch here. Otherwise, it will not be able to find it. Okay, so I just deleted my assembly and a new file. And as you can see, we need assembly instead of modeling. Okay, and you want to make sure that file is in the file that you in the folder with all the other parts. Okay, so and you also notice we have the file extension is exactly the same as modeling, which is .prt. So it's a good habit to have something in the name that says this is an assembly. For example, just leave assembly there. Okay, so that's the top assembly. And once you create the part of the assembly, it'll jump out this window asking you which part you want to insert into this assembly. We don't have anything open yet, so we don't have any loaded parts. What you can do is you can open this folder, and it should be able to locate your parts, your folder. So you can insert one of the parts, let's say blade. Okay, so that's a little bit preview. Then you have some options to insert where you want to insert. Usually you can just say absolute origin, then you'll be able to move that. So in case you have some parts on the screen already and you want to say insert a pin in a hole, you can use by constraints. Use constraint right away before you insert, then it'll insert into that hole. So we'll do absolute origin first, then say OK. And that is the first part in this assembly. Okay, as you can see, we're in this assembly navigator, and it shows we have one part. And you can insert individual part. You can also insert sub-assemblies. So for the sake of sub-assembly, I will demonstrate that here. So first I will create a sub-assembly. Let's say for the handle, okay, because we have handle and the grip, two parts, and usually they go together. So we can put those two parts together. Let's say insert both of them, multi-select. Okay, so once you select the both, they should be perfectly matched because we created the grip based on the handle, and I will insert that to the absolute origin. Say OK, and before you do any movement on the parts, for example, if you want to move this part, we need to add a constraint to put those two together, because once you move it, it's hard to find where they match. So just to cancel, and if you choose cancel, it will be lost. Okay, and at the bottom, right? So this portion is most of the assembly tools. Then we have assembly constraint here, and be careful, this is not geometric constraint. Geometric constraint is for your sketch, okay, which is here. Then we have assembly constraint is for the relationship between parts in assembly. So assembly constraint, I would use a bond, okay, to sort of glue those two together. So create constraint and say OK. Now we have this subassembly, okay, created. Of course, we can do the other handle. So let's say we have one subassembly, then we do the other handle for handle, the red one. So, and we need the handle, but we also need this, the red. So we have two parts, and we're gonna reuse the handle because it's symmetric at left and right. All right, and again, we're gonna apply a bond between them first, so they don't move relative to each other. And if you notice in the first subassembly, it's on the left side, and this one is also on the left side. You can probably just rotate this now, or you can rotate that later in the master assembly or the top level assembly. So let's say we're done with those two assemblies, sub-assemblies. So we'll go back to the top assembly. And here you want to add more components. I was trying to find that shortcut. So add components. It's at the bottom. Okay. And we have a couple parts loaded as well as sub-assembly. So I want both of the sub-assembly, and just say OK. And they do overlap because they were, basically built at the same location. And take a look at the tree. We have sub-assembly, and you can tell from the structure. Okay, we have top level, and that's the second level, one level lower sub-assembly. You have two parts in the sub-assembly, and we have a constraint in that file. So if you have complicated parts machine, you probably want to use sub-assembly. But for this case, we use this just for the sake of using this. Alright, so let's move one of the parts away. Okay. And as you can see, if you want to move something, just right click, and we have this symbol. Let's move, and good old hide, and you can change the color. You can apply constraints, and then you can modify that part. Okay, and this is, you can open that part in an individual window. So let's say if I need to change the dimension of that hole in this part, and modify that with the assembly open, what we can do is we can right click and make this working part. Okay, so now you can see other parts are grayed out. We're working on this handle as if we are working in the part. So you will be able to modify just as you were doing the modeling for this part. The only difference, you can see other parts in the assembly. And if you want to go back to the top level, just double click in the assembly navigator. Okay, then you will be able to get back. So whichever parts you want to work on, just double click, then you will get right into that part. Sometimes you feel, if you feel the other parts are sort of in the way, then you can right click and make display part. So this way, it'll open the part itself. Then it's just like you're doing the modeling. Okay, so we go back to the top assembly, and let's start putting things together. So first we need to rotate, okay, this handle 180 degrees. So we choose move, and this is the dynamic coordinate system for moving things around. You can move x, y, z direction, and you can also rotate on 3 axes. So if we want to rotate, we can just drag this ball here, and take a look at the number on the little window underneath my cursor. It snaps to 5 degrees, so it's easy to rotate 180 degrees. And apply. Okay, and let's see where the origin is. Okay, the origin is here. We can probably fix one handle first. Excuse me. So because this is sort of like your finite element analysis, everything is not constrained if you don't have any constraint. Okay, so if you don't fix one point, everything can flow around. So what we do usually, we just apply a fixed constraint for one single part. So once you fix that, it's like you're putting the desk on the floor, and everything on top of the desk will have a place to go. Okay. Alright, so this part is fixed, then we can start to use constraints to put things together. Okay, so we will use extensively those assembly constraints. Before that, we need another blade. And origin, okay. Then again, we need to rotate this part and choose move. Rotate 180 degrees, which is not that axis, it should be this one. 180, and okay. So let's put those two blades first. In this assembly constraints, you can look at the details about how those things work. We use fit for cylindrical faces, so there's a hole and there's a hole, and the fit only works for the same diameter holes. So we use fit for this face and that face. Okay, they will align the hole together, but it will not constrain on the axial direction. As you can see, you can move things up and down like this. You can move up and down, but the two cylinders will be aligned always. All right, so how do we constrain, prevent them from moving away on the axial direction? And we can use another constraint. In this case, we know the inside faces of two blades should be touching each other, right? So what we do is we use a touch align. You don't have to change this subtype. We want this face to touch the same face on the other part. Okay. So they will keep together, and that's there. And If you want to see degree of freedom, you can right click and take a look, show degree of freedom, because both of them are not anchored or fixed, so they have 6 degrees of freedom. Okay, and if you take a look at this none, because we did a fixed constraint for this part. I think we did that in the subassembly. So let's try to drag this. I'm not sure if that'll work. Okay. Apparently it's not. So we want the this fixed constraint applied to the subassembly. So we'll just work in the top assembly level. And okay, so we have this fixed for the whole subassembly here. Then next we will put this scissor head onto the handle, and again we will align the holes together, so we will be using fit constraint. And some will say okay, we have concentric here, why not use them? Concentric, it's a little bit different. Concentric is for circles, and fit constraint is for cylindrical faces, so face versus circle, and that's 2D geometry versus 3D geometry. Circles are 2D geometry. So once you use concentric, they will not move on the axial direction at all. There's no movement. It's only it's within a 2D plane. So if we apply 2D, you can see we cannot pick up cylindrical faces. We can only pick edges, which is a circle. Then concentric to this one. And if we try to move this, the only direction you can move is really wait. Somehow my mouse is double clicking. Okay, I need to move this. Maybe it's better to because I clicked on this part. So if I right click on the subassembly and move this, you can move, rotate, but you cannot move on axial direction. Nothing happens because it's concentric. It's a constraint that'll put two circles in the same plane and on the same center, of course. Alright, so for this case, you can use concentric sometimes. For this case, if you want to use concentric, you have to pick the two circles that's touching each other. If you pick the top and the bottom circles, that'll be a problem. Alright, now what's next is those two holes on the scissor blade. They goes into those two holes. So we can use fit because they are not coplanar, and fit constraint for this cylindrical face to this one, top or bottom, that's all the same. They share the same axes. Now for this circle, can't see it. You change to wireframe. We'll pick this cylindrical face to fit into this cylindrical face. So it's almost done. Let's move this handle. And I'm clicking on this handle, so it'll probably just move this handle. The grip. So let's click on the subassembly and try to move. So that looks like it'll work properly. And if we look from the side, it also looks pretty good. But if we do one more thing, if we move the blade, remember we use the fit for those two holes. Yeah, if you look from the top, it looks pretty neat. But if you look from the side, you can move X and Y. So here we need one more constraint to make this centered to the handle. So I set center because we're gonna use center constraint. And in center we have subtype 1 to 2, 2 to 1, 2 to 2. So basically you want to put one object in between our two objects, or two objects that has one in the middle. So 2 to 2 is you want to align the center of two objects to the center of the other two objects. So we're going to use this. We have this top and bottom surfaces. Once you click those two surfaces, it'll automatically find the center of those two surfaces to be centered to probably this face. And usually the pair of faces, I will pick parallel faces. And I've never tried to pick, or maybe they never work well. And as you can see, it doesn't work well with non-parallel faces. So I'll go back and pick parallel faces. That is the first pair. Second pair is this one. It should be parallel. And you can see this thing jump between the handle. And that is centered. We can hide this and which blade? This blade. F8, you can take a look. It is perfectly centered. And now we probably don't need a center for the other side because fixed, then concentric, though this one will not move on the Z direction. Then we have center for this blade. We have touch align for that blade. It should not move. We can check by using this show degree of freedom. You can see this only can rotate in plane. Okay? It will not move out of plane. So in this case, everything is done because we have a fixed for this handle. So this one will stay fixed, not moving, and we can try to move the red. Okay, the red handle. And if you look closely here, in the real thing, this step actually prevents the snip from opening too much. So from the smallest closed place is you can use the constraint. When we built this part, this edge and this edge is vertical. So when this closed, fully closed, those two faces should be parallel. Okay, if you apply parallel constraint and look from the top, that should be the closed state of the snip. And the other one, the maximum opening is determined by this gap here. Okay, once you open this up, they will get closer and closer. Eventually, they're gonna touch each other. So if you look from this direction, and I have tried that, you use touch align for those two flat surfaces. They will not actually touch because in NX it thinks this flat surface is infinite face. Okay, you won't touch two infinite faces. As long as one of the face is not parallel to the other one, they touch. So it doesn't really make sense to touch two parallel or flat faces. However, you can touch this flat surface to a cylindrical face. It's like you put a tire on top of ground. It actually works. And let's say, okay, this is red because it's over constrained. Why? Because we have this parallel between that. This parallel, that's the closed state. So we need to take this out, and that'll be the maximum state you can get. Also, we probably need to apply the same thing for that side. Let's try to move it. Yeah, it's not moving. Alright. So if your model is perfectly symmetrical, it should be, because that's the same parts, and that'll be the maximum opening you can get. If you want to make it open even bigger, you can double click the blades and change the dimension in one of the sketches. probably this one. Okay, you can make this dimension a little bit bigger, so this face moves higher. Then this whole thing will open more. Let's say if I change it to 0.3, hit enter, you can see this gap is much bigger. I'm not sure what will happen with that much difference. I say OK, and as you can see in the background, it's already open much bigger than before. And if I go back, okay, that's the maximum opening I got now. Alright, let's finish the sketch and not changing anything. Go here. So also sometimes you might want to change the color of a part so they look different in assembly. Once you have 100 parts, you can do something like this. Right click, and there's a symbol here, edit display. Then you can change the colors. Say you want gray, apply. Then we select a new object, okay, and inherit the color from this. Apply. Okay. And if you change it to studio, that'll show your decal on the parts. Okay, so that's pretty much everything in the assembly. One thing is sometimes you want to take a look at the cross section. So let's say what's inside this handle really between those two parts. You can create a new section. Then you can change the orientation. Let's say, right, I want the XY plane, and the Z coordinate should be 0. So that's right on top of, right on the XY plane. Then that'll give you a cut of the parts. That's the inside the handle. You can check this section, make it show up, then it'll show the edge of the cutting. Okay, so that's the cross section. If you don't want to see that anymore, just double click, it'll hide it, and uncheck the box, the blue lines will disappear. So that's the section view. Then next is the drafting. We ask for just one draft for one part, so we can create a new draft. There's two ways to create draftings or drawings. First, you can change this to drafting, so you will have your drawing inside this file. That goes the same for the parts. You can start a drafting and there will be no extra file generated within this file. And the second way is create a new file, a new drawing file, and reference that to the existing file. And this is actually the recommended way by NX manual, so we'll just follow that. And we'll just start from the blade. And since we use a template, that will give you the company logo and those sort of things here. I'm gonna just leave it alone. Then you will have automatically open a creation wizard. And if you like this, you can change things around. You can say I want 3 views, I want 4 views, things like that. But I want nothing. I just want to do it all manually. So we have creation wizard, which you just saw. Then we have base view command. So now you just, okay, I want to insert just one part or one view, and the ratio will make it a little bit smaller. Okay, so that's one view, and once you put on drop down the base view, it'll automatically create a projected view. So let's take a look in the part navigator. The first one is your base view, and then the second one is a projected view. So you can have a projected view associated to the base view. So this one is the master, this one follows the base view. Here you can have another base view, say geometric, isometric, and the ratio, something like this. And okay, now if you look at the tree, we have two base views and one projected view, and this one is associated to this top view. So if I move this view, that will follow, but this one is standalone individual. Okay, they're not related. So that's for the views. And dimension. Remember, we have dimension in the sketches, so you can import the dimensions from sketch. So we have a command called feature parameters. Basically, you will import parameters from a feature, which is sketch, extrude, this kind of things. But in terms of the feature available for the drafting, you only have sketches. Okay, and you better remember which one is the sketch for this bottom. I guess it's the first one. Then you need to click the second button to pick which view you want to put that sketch dimensions in. So you can select from the working space, so you can select from here, top view 1, apply. So those are the dimensions from your sketch, and they are at exactly the same location where you put the in the sketch. Okay. So that'll save you some time adding dimensions. So you can adjust them. And what if let's say you want more dimensions? Now we don't have any dimension for the blade part. You can do just like in sketch, you can use infer dimension. Then it depends on what you click. If you click that, that's a little fillet there. So then if you click a second item, center of the arc, it'll show the distance between them. Then probably come here, you can add some thickness of the parts, and okay, how much from the top to the bottom, depends on which side you're pulling out. Then the total height of the blade, okay, then maybe the height on the tip. So just be careful which point you're picking, because you're picking on a 3D object. Sometimes you pick on some curves behind this face, which you can't see. Okay, so we got some dimensions, and I'm not going to talk about how to dimension this properly. This is really a drafting class thing. And however, we'll say if you want this dimension to be fraction instead of decimal, you can right click and then you have a style option. In the style option, you can change the units. Okay? And in this units tab, you have the format. You can change that to fraction for this individual ones. You can change the size of the letter and the size of the arrow. Wow, that's too much. Okay, and in the, I think where that is, in dimension, you should have the ability to change the precision. So this is 16 So you can change to 64th and apply, because that's exactly 9/16, so it will not change. And you can change the decimal points on those dimensions. So you can actually just double click, and this is a little bit easier to change. You can have 6 decimals, and yeah, that's exactly 0.31, so there's no more zeros to show up. This, alright, maybe you can go inside here and change these different formats. So there's a lot of details inside here you can play with. Okay. And what else? So for this isometric view, you probably don't want just the wireframe. You probably want something fancy like shading, colors. So double click, which is the same as right click, and in the style, you can change the shading. There's a shading tab. You can change that to fully shaded. Take a look, and you have this shaded view. Okay. Then let's do a cut. Okay, let's do a cross-section view, and which is here. That's a straight cut. You have some options to do revolve the section cut, those things. So a section cut, first, which view you want to do the cut. Okay, you have to pick a view. So that's the excuse me. Parent is the view of the for your cut. So you can pick the view first. So now we're working in this view. Then where do you want to make the cut? So we can cut this circle open. So that's the location of your hinge line. Okay. Then you can cut this way, or you can cut that way. Let's see, we can maybe cut this way. It'll be interesting. Okay. So we have this countersink hole as countersink, and then we have the blade partially cut, and that's a nice curve there from the swept. Okay, then you have the name for this section view is section AA, and then you have this line here. And seems like you cannot drag those arrows. Okay. What's next is the sometimes, okay, you can see the background of this cutting. Okay, the area with hatch lines. You can double click, and I think you can change the margin. Apply. Will that be smaller? I think it's, or this one, distance 0.1. There's a lot of things you can fine tune the display, and this line here is actually on the back of your cutting as a cross section. So sometimes you don't want to see them. Okay, if you cut the head of a car, then you don't want to see everything 1,000 parts behind this cutting plane. So what we do is, again, in the style menu, you have a section tab, and by default the background is on. You can turn that off, apply. So that's where the cut will intersect with your model. So sometimes this kind of a section view is useful. Okay, just give you an option to do that. And I think that's all for the sketch. Okay, you have much more options here to go deeper. You can just try them out. Okay, so in the project we will ask for 2 views plus 1 section view with some dimensions. And I know it's hard to properly dimension a part, especially if you don't have any experience on drafting. In the real thing, you would have tolerance on each of the dimensions. If you don't have tolerance, people don't know what do you want for the machining. They will be look like that. Okay, so everything pretty much will be like that. And you have surface roughness. You have probably a lot of remarks saying this part should be heat treated somehow, or the process should be noticed, and something should be notified. Da, da, da. Okay, so that's for the drafting, and you can save this part. Okay, now because our drafting is associated to the model, so we have that's the drafting. We have the subassembly. We haven't saved the top assembly yet. So that's all for the assembly and the drafting for our project. Okay, thank you very much.